My name's Brock. I'm talking on behalf of the indexing company. We are trying to build the future of data infrastructure. So we're calling it Data 3.0. And really what this means is we're trying to lean into the power of decentralization to bring that about. So a little bit about me. This isn't my first rodeo. My co-founder Steven and I, this is our second Web3 company. We were trying to do real estate back in 2017 on chain, but getting real estate agents to install MetaMask was a non-starter. So went from there to Coinbase, and now we're back trying to do indexing as a service. So what's the problem? For anybody building in Web3 today, products are tough. You need data. That data's out there. You know it's there, but trying to get access to it is really difficult. Building in-house is hard, and everybody ends up just trying to reinvent the wheel. And the existing solutions, they just barely scratch the surface of what's possible. We're sort of seeing the same paradigms from Web 2 repeated now in Web 3. There's centralized solutions, API first, they get expensive at scale, and they're incomplete and inflexible. So ultimately, what this means is even if you're paying for another third party, you still have to build in-house. So we're different. Where other solutions right now, they're going out, they're grabbing Web3 data, they're putting it into a centralized database and reselling that access, usually over an API. We actually process that data in a distributed or decentralized way as well. So the data is distributed, we process it distributed, and then we deliver it to your localized databases. So you get full control end to end, and the resulting data is in a spot that you control at the end of the day as well. So really, we're daring customers to love their data again. Data doesn't have to suck. So spoke a little bit about this. We embrace the power of Web3. We're distributed first. We let customers define their data. Because we're distributed, we can also lean into the economies of scale. So enterprise grade at a fraction of the cost. And usually, customers of ours are saving 50% over building in-house. And so really, it's pretty simple. Customers define their data sources, transformations, where they want it delivered, and then they get back to building. Infrastructure is boring. It should be. It should just be predictable, configurable, and empower you to do whatever you want to do. And so another way to frame this is we're an ETL for Data 3.0. So we let you access data from any Web3 source. So it could be an EVM chain or not, it could be Farcaster, even Dogecoin, whatever it might be. We've got distributed processing architecture. And we're building out right now, which I'll demo in a sec, some batteries included templates. We also have custom code support. So if you want to run your own transformations in this distributed network, that works just as well. And all of this can be delivered wherever you need it. So your database, your stream, your webhook, you name it, we can deliver it there. And again, economies of scale for everyone. It's your data, your way. All right, demo time. We built this overnight, so apologies. We've had the infrastructure, and so this is our first stab at a GUI now. So we'll see how this goes here. This here is what we're calling our console. So I was talking a bit about how we have configurable data architecture, and this is our first stab at it, at visually showing that. So here you'll see this concept of feeds. These feeds are templated ways of accessing data and kind of define what it is. First one here is Farcaster. So if I click into this, this is something I had already set up this morning. This is real-time data from Farcaster being piped into a database. It refreshes every 5 seconds. You can see how many total records have been processed, how many beats have been processed, when was the most recent timestamp. You get views into the data. So these are actual casts being sent on Farcaster right now. And you can see the SQL query that's actually generating this view. And so the kicker with all of this is going into a real database. So there's actually a connection stream behind here. So that is not something internal to Indexing Co. This is something that has been deployed on behalf of my pseudo company here. And this is now my data, and it's all flowing in real time. So this is already set up, and if we now try setting up a new one, can kind of show the power of this distributed computing and how fast it lets us move. So we'll do token bound accounts. UArch is a little rough, but we can do a comma-separated list of different chains. So we're going to do Ethereum, Base, and Optimism. All right, so we're going to get a data set of token-bound accounts on those 3 chains. We hit go. And so what's happening here, it just deployed a database, deployed the infrastructure, and it deployed the configuration to start processing this data in real time. Now, you'll see there's no data currently. There's not a whole lot of token-bound accounts being deployed in real time. So one of the things we can do here now is backfill data. So this is usually really expensive, really slow. We're going to get all time, all token-bound accounts for Ethereum, Optimism, and Base. We should be able to do that in real time. And you'll see here we can select from different databases. We're going to use the hosted PostgreSQL one that we saw earlier. We could also do MongoDB. We can add a different data source. We're going to hit go. We'll see how this does. So again, this will refresh every 5 seconds. You'll see we got 1,000 in, about halfway done. And yeah, this should be just about done. There we go. So that was all token-bound accounts across 3 different chains throughout the history of those chains. Real data here. We're seeing timestamps, chain, account, token contract. Again, we've got an SQL query that's powering that view. And this is still going into that database. So if we were to copy this and go into a terminal, we can then also copy this same query and view it there. So this is real data, real database. It's flowing in real time. And because it's in the database, you can also structure other queries. So say we wanted to know counts by chain. There you go. And so this is kind of just showing the power of what we're trying to do and leveraging that distributed compute to then go process multiple chains in parallel, in real time, and deliver data sets that are structured in a way that makes sense for the use case. So hopping back over here, yeah, thought that actually worked. Again, kind of a recap. What we're doing, we're letting customers configure their architecture. They can deploy dedicated infrastructure from those configurations. Then they can receive real-time and historical data using all of that. And at the end of the day, you all can get back to building. So where we're at right now, just kind of a short roadmap. Most people talk about Web 1, 2, and 3 as read, write, own. We like to think about it in terms of computing. Web 1, local computing. These are servers and computers that are run maybe in a home office. Cloud computing is Web 2. This is the Googles of the world. Web 3 plus, we see this as everywhere computing. So because we're already doing this in a distributed way, we see the potential here for not just having to run nodes, but for every device to be able to process data. So right now, this is something light enough. Our nodes are only 1 gigabyte of RAM and 1 CPU. So we envision a world where this could be a network where mobile devices are indexing on demand, and we can ultimately just eliminate the need for most APIs. So that's where we're headed. We're kind of somewhere in between right now. That's the vision. That's all I got. That went off without a hitch. So yeah, please reach out. Any questions? Yeah. Yeah. So the question is, what's the difference between this and a subgraph? So a subgraph, one, you gotta know how to code. So you gotta be able to configure that code yourself, right? And then when you do and you deploy it, subgraph architecture actually localizes all the data onto a single node. So even though it's built as a decentralized network, that subgraph exists on a single individual node, and you don't have access to the underlying data. So this is data in your database versus somebody else's. Yeah. Any others? Yeah. Yeah, so the question is about incentives. So right now, we run the distributed network. So this is essentially shared computing within our ecosystem. The near-term future that we're rolling out is what we're thinking of as neighborhoods of nodes. So it's kind of a business-first approach where a business might run their own neighborhood, and they don't need to pay themselves to process their own data, but if they'd like to lean on the rest of the network, then there can be an incentive mechanism between businesses. Yeah. Then were there two more? Or was that? No, okay. Cool. Any others? Awesome. All right. Thank you, Des.
Future Primitive